Okay, this is the Energy Loss Lab by Tatum and Allison. Our hypothesis for this was if there is loss, then it will be constant, meaning over time, as something happened, the loss would be consistent for it and energy would be conserved the same. Our materials were a bouncy ball, a motion sensor and laptop, which we used to find velocity, height, and time, and a scale to measure the mass of our bouncy ball. What we did was we chose a bouncy ball and weighed it, and then we set up a motion sensor for finding the different variables we needed, and then we dropped the ball beneath the sensor and let it bounce until it stopped bouncing. And we then read the graphs provided by the motion sensor in order to determine velocity and height, and therefore GPE, KE, and later on loss. And this is what happened when you drop the ball, except for it stayed basically underneath the sensor the whole time, but that's kind of how the heights went, and eventually it stopped. Our given data was the height, which was 0.89 meters, our mass, which was 0.01 kilograms, our G, which is 9.8 meters per second squared, and that's always the same on Earth, and because gravitational energy is always the same on Earth for that, the pull. And then our initial velocity was 7.18 meters per second. This is the energy chart we came up with, which is we have energy before J, energy before, which is in joules, and energy after, which is in joules, and we have GPE, which came out to be 0.08722, and then 0. Our KE, which came out to be 0, and then 0.257762, and then our loss, which is just a variable, L. And this came out to be a loss calculation of, our loss was negative 0.170542, and the negative is there because even though that doesn't happen like with the equation as you solve it, that is like a given thing for a loss, it's always going to be negative. And then we found further loss calculations, so we did from different heights, and we came up with these. And these, then we found our change in loss, and these are in joules, this is in meters, and our change in loss showed to be actually inconsistent. With the conclusion that loss is not constant, which goes against our original hypothesis that it is, and instead it decreases over time until it reaches 0, and this is because loss is negative, so as it gets bigger and bigger, it's getting closer and closer to 0, and 0 is where it stops, and there's no more loss. It'll just kind of roll away. Possible errors for this include incorrect readings of the motion sensor, calculation mistakes, misinterpretation of data, and misinterpretation of data and incorrect readings of the motion sensor graphs kind of go hand in hand because we could easily misinterpret the different graphs that are given by the motion sensor because we never used it before and therefore it was new to us, which leads to many possible human errors. And then calculation mistakes are always just kind of a given because there are always problems with negatives and things that should be something but are not interpreted that way. And what we learned from this is that loss is not constant, which is our revised hypothesis, and that motion sensors allow for calculations of GPE, KE, loss, velocity, time, height, and then other things such as momentum, which you could use in other forms and other problems like we had in previous units. And that was our energy loss lab.